So we can start with the graphing form, or for the form that shows us the transformations, and put it back into the factored form here. So starting with the graphing form, we can see that we can graph this based on this information. We have a horizontal shift of -1. We've got a vertical shift of +3. And then since the expansion is just 1, we can just go use our reference points here and here. Okay, and that's what the graphing form, or the transformation, allows us to draw. But we can go in the other direction, and instead of using the graphing form, we can put it into the factored form. And the nice thing about this form is that we can see the zeros and the y-intercepts fairly easily in this form. So to do this, I need a common denominator. I need to combine these terms here, and here, with a common denominator. So I end up with 1 over x plus 1 plus, so the common denominator is going to be x plus 1, so I need x plus 1, x plus 1. I can now, with the common denominator of x plus 1, add these together, so I end up with 3x. 1 plus 3 times 1 is going to be 4. So there is my factored form. And I can see that my root, the 0, is going to be from the numerator at -4/3. And I have my asymptote at -1. When I plug in 0, I get a y-intercept of +4, which I can see there. Okay, so although I drew it using the graphing form, I can go about this slightly differently and use this factored form. So the factored form, I'm going to use my denominator to get my vertical asymptote. I'll use a limit as x goes to infinity of 3x plus 4 over x plus 1. We can see that the +4 and the +1 become insignificant, so we know that the limit's going to be at 3. So I draw in my horizontal asymptote for my limit. Again, notice that's the same as that vertical shift. And then I'll plug in some points. So my x is 0, x is 0, y is 4. That's going to be that point right there. I can solve for the 0, so when y is 0, x is -4/3. That represents that coordinate right about there. And I can sketch in my graph in this way, using those points instead of the previous points that I used. So again, these are just alternative ways of dealing with the same problem. This is from a transformation perspective. This is from the previous rational functions perspective. So the graphing in factored form, is one thing to note is that regardless of being in factored or graphing form, the denominator is going to be the same, and that's going to give us our vertical asymptotes. So those are going to be something we can identify very quickly by just visually inspecting the equations.